Today we're going to talk about how brain-computer interfaces can be used as assistive communication devices for patients who have lost the ability to speak or type. We're going to talk about the different ways that brain data can be recorded and transformed into communication, such as speech or text, or how people can use brain signals to directly operate a computer. I'm curious, and I want to ask each of you, let's posit that the technology exists to have 10,000 neurons, readability from 10,000 neurons in any brain area of your choice. What's the assistive communication device that you would build in that case? Like, what's the brain area you'd want? What's the modality that you would choose?
I'd start by asking the end user. It's going to depend what they want and what they need. I think people with different types of injuries are going to ask for different things. I think people who can't talk or communicate really fast at all, communication is going to be a major need. Someone who can perhaps talk but is paralyzed from the neck down probably wants reach and grasp and things like that. So there's not going to be a single application.
Let's say for communication for someone who can't speak, can't type very easily.
I think it's a Utah array style resolution from what we know, right? Applied in the areas where ECOG language decoding has worked well. So I'd want to put those electrodes all up and down the motor strip.
Just to chime in on your previous question about like optimal decoding and what to decode to get maximum speed, I think I would probably try to combine decoding of phonemes with decoding of semantics with, a Paradromics style array where you have tens of thousands of electrodes and you can put them wherever you want. And kind of combine those two in a Bayesian way, along with maybe a language model to try to accelerate the decoding so that it's at the speed of or even faster than human speech. So the person only really has to think about what they want to say, like the sentence they want to say, and then you decode that automatically.
Actually, Beata, I'm glad you raised the language model because, Frank, looking at your work, the language model is really important.
Obviously, language is a hugely useful constraint because there's so many, different statistical relationships between all the different words. And so for handwriting, we were able to get about 95% accuracy without a language model. So still, not bad, but frequent errors, 5%. But then with a language model, we were able to get above 99% accuracy. So it's definitely very useful. And I think we've all experienced that, right? When typing on a smartphone, we make a few errors here and there, and as long as there's not too many, language is very constraining. Usually it corrects it to the right thing.